What we have in front of us here today is a Galaxy S7 Edge model G935F that has come in for some repairs. The customer has stated that they're experiencing two problems with this phone. The first time the problem happened, the screen went completely black and a blue LED came on in this region here, and they were not able to use the phone at all. They weren't able to press any of the buttons to restart it. Normally if you press the power button and the volume down button and you hold it for 20 seconds, the phone will restart. They weren't able to restart the phone. They had to wait until the battery completely died, and then they were able to put the phone into recovery mode by pressing the volume and the power button, and they were able to reset the phone from the recovery mode. After they reset the phone, that issue never came back. The blue LED and the black screen issue never came back, but every so often the phone will just freeze and restart itself. So what we're going to do today is we're going to attempt to diagnose this problem and repair it. Put it down here, and I shall switch on the power supply. Okay, so straight away you can see on the screen that it's pulling about between 730 and 820 milliamps of current, and there's no output on the screen. If we press the power button here on the side, there's nothing. So at the moment the phone is pulling an irregular amount of current, and it's not starting up or booting up, and the screen is completely black. So straight away we can tell from the current consumption that something is not right here, and we need to look into it further. Right, so we've managed to get our back cover off our phone, and the first thing that we want to do is we want to establish if we are getting voltage at the point of the battery connector. Okay, once we've established that we're getting voltage here, then we can move on to other components. So we want to get that out the way first. So I'm going to go back under the microscope, and I'm going to come in with the digital multimeter leads, and I'm going to measure the points at the battery connector and see if we're getting voltage at the point of the battery connector. So let's do that now. So this here is our battery connector here. So let's switch the power on. So you can see here that the phone is pulling maximum about 600 milliamps. So what kind of voltage are we getting here? So as you can see here, we're not even getting 1 volt at the battery connector, and it's just fluctuating at the moment, up and down, up and down. So now what we need to establish is why we're not getting any voltage here. And for that we shall go to the service manual and have a look what the service manual says regarding this. Okay, so we've got the service manual open here in front of us, and this is the section regarding the charging port. Now what it says here, the first thing that it's advising us to do is insert our power USB insert and check if you're getting 5 volts at L7022. L stands for inductor, so it wants us to check if we're getting 5 volts at inductor number L7022. If we're not getting 5 volts here, that would indicate to us that the sub PBA, which stands for the sub printed board assembly, is damaged or not functioning correctly, and the service manual is advising us to replace the sub PBA. So what we're going to do now I want to make this as easy as possible for you, so I'm going to go through this section by section, one bit at a time, and then we'll take it from there. Now, the first thing that we need to do is we need to find out where inductor number L7022 is located on the board, and I also want to show you what it means by sub PBA. So let's go back up to the board view, and I'm going to show you where L7022 is located. So just bear with me for a second. Right, okay, now this here is your sub PBA or sub printed board assembly. Remember, I was saying that the phone consists of two boards. One is the main board and one is the sub board. The sub board, when they're talking about the sub PBA, this is what they're referring to here. It's got the two buttons that you have on the front of the phone. It's got the charge port, and it's got some other components as well, here and here. So that's the sub PBA. And if we go up here, this is the section that we're interested in. So have a look at this. This is the back of the PBA, the main PBA, the main printed board assembly. And this is the section here that we're interested in. So we're going to zoom in now, and I'm going to show you where that inductor is located in this region here. Okay, so this is the section that we're interested in here. The first thing that the service manual tells us to do is to check if we have 5 volts at L7022. If we don't have 5 volts here, it is advising us to change the sub PBA, as most likely that is faulty. If we do have 5 volts here, we can then move on to the next section or the next part to test in the service manual. So let's check this first, and we'll take it from there. Okay, so this here, all of this here, is the main PBA printed board assembly. That's what it's referring to when it's talking about the main PBA, okay? And this section here, going all the way down from here to here, is your sub PBA or sub printed board assembly. Now, the component that we want to check, that inductor that we want to check, is on the other side of the board in this region here. The inductor that we want to test, can you see where my thumb is? It's located in this region here. Okay, so we've got the section that we're interested in under the microscope here. And this inductor here is what was referred to in the service manual. Let's switch on the power. As you can see, it's starting to pull about 600 milliamps. And as you can see, we are clearly getting 4.97 volts. Okay, so that tells us our sub PBA is fine and we don't need to replace it. It wants us to check if we are getting 5 volts at capacitor number C7149. If we're not getting 5 volts at capacitor number C7149, then what we need to do is we need to replace IC number U7009. Okay, we're back under the microscope now, and I want to show you, this is the capacitor that was mentioned in the service manual, C7149, and you can clearly see that we are getting 4.97 volts here. So, and this end is ground, so that would indicate to me then that this IC is fine and there's no issue with this IC. We can now proceed to the next step. Okay, so we've completed the first 2 steps of the guidance in the service manual, and we have confirmed that our sub PBA is fine, and we have also confirmed that IC U7009 is fine. Now what the service manual is asking us is the battery charging or not? And because we've already tested the points at the battery connector, we can confirm that the battery is still not charging. So what the service manual is now advising us is that we need to, if the battery is not charging, and we can confirm that it's not charging, we need to now replace U7011. So first of all, let's locate U7011 on the board view, and we shall then proceed to discuss what options are available and what we can do. If you have a look here, U7011 is located in this section here. Okay, so we've got our board turned over here, as you can see. The IC that we're looking for, the faulty IC, is located in this region here. We've got our power connected to our power supply. We're going to switch it on and we're going to provide power to the board. And then what we're going to do is we're going to come in with the thermal camera and see if heat is being generated in this area here. If there is a significant amount of heat in this area here, that would indicate to us that this IC is indeed faulty, right? So let me just mention to you the tool that we're going to use now to do this is this tool here. This is called a thermal camera, and we as technicians, what we do is we use this tool here to find hotspots on the board. Normally when you have a faulty component, it will light up with heat, okay, and you use this tool to detect that heat. So that's what we're going to do now. Okay, so you can see here that there is no significant heat in that area of the board right now. So let's apply some power and let's see how that changes. Okay, straight away you can see how much heat is accumulating in that area over there. It's a significant amount of heat. In fact, it's getting so hot that it's warming up the whole of that section there. So there's clearly a short. What that would indicate to me, I mean, looking at it from this angle here, it looks like to me that the short is within the CPU itself. And for me, that's a no fix. I'm going to go back under the board view and I'm going to tell you why. And I'm going to tell you what are the options that you've got available if you've got a CPU short like this. The S7 Edge is one of my favorite phones. I actually learnt micro soldering from this phone and this particular board here, the G935F. It's one of my favorite boards for micro soldering because the components are really nicely spaced out, and for a beginner it's easy to come in and get under a microscope and start to fiddle about with these components, and it's just a really easy board to work with. But one thing I refuse to do is touch anything on the back side of this board, and I'm going to tell you why. So if you have a look here, this is the back side of the board, and under this side of the board here, okay, here sits the CPU. On top of the CPU is another IC which is for the RAM, and then this IC here is for the storage, okay. And do you remember that the IC that we're talking about, that we spoke about in the service manual? That IC is located here, okay. Now if the service manual indicates that you need to remove this and start messing with stuff under here, that's where I would call it a no fix, and I would say nope, now is time to replace the board. And I'm going to show you why I'm saying that. Back under the microscope, let's take a closer look here, and I want to explain to you what I'm talking about. So this here is the cover that you have to remove, okay. Now you have to heat this cover up here to about 380 degrees, and you got to carefully heat around the edges. You don't want to come too much in the center here, because this is where the IC is, and you don't want to come too much in the center in this region here, because this is where the CPU is. And now, I mean, I can do it now, but when I was first starting out, I used to have real problems with this area here. Every time I used to try and heat it up, what I used to end up doing was, I mean, I've done this one now, so I'll just show you now. Let me just remove this, and I'll show you what I'm talking about. This here is the IC that is referred to in the service manual. And then right below that is the CPU. This is the CPU here, Okay, so I'm just change the focus on that for you. Yeah, so this is the CPU. So when I was starting out, as I say, I can do it now, but when I was starting out, every time I used to heat up that piece of metal covering all of this, I used to end up overheating the CPU, and I used to end up damaging the balls underneath. So it's an acquired skill, you know what I mean? You have to practice. I mean, I had to go through at least probably about 15 or 20 boards before I could do this properly without damaging without any damage to the CPU underneath or to any of these components underneath. So, you know, that's a lot of time. It takes a lot of time to do that. And what I was trying to say, anyway, getting back to what I was trying to say is that if you have to remove that metal cover here, then, you know, it's very detailed work, right? And it's going to take you, if it's this, you got to remove this. You got to remove the all of the old adhesive underneath. Then you've got to get a new Max 77854 IC, and you'll have to order it from China, obviously, unless you've got some boards lying around. And even then, when you put it back on, there's no guarantee that it's going to work, or you may get one even from if you order it from China, and even that one might be faulty. So you can't say, you know, for sure whether it's going to work or not. And so you'll have to put in a lot of work beforehand before you're going to find out what the results are. And you know, if you're thinking about taking this CPU off and reballing this, you know, you might as well forget it. I'm telling you now, the amount of work that you're going to have to do, and it's just not going to be worth it. I'll show you. I've got another board here. I'm going to show you how many pins there are under this CPU, just to give you an idea of, you know, what you're heading towards, if you like. So I've got another board here. Just have a look at this. Right, this is one of the boards I worked on when I was starting out, when I was learning to micro solder. I mean, just look at the number of pins that are under this CPU, right? It's just madness, you know, trying to do this. As I say, if it's worth the money, fair enough. You know what I mean? If it's something that, you know, if you're doing it as a hobby and you want to learn, that's fine. Go for it. You know, take it off, mess about with it. You know, try and put it back on, see if you can get it working. That's no problem. But if you're doing it as a business, honestly, it's no point, because I'm gonna show you now. I'm gonna go onto eBay now, and I'm gonna show you how much these boards cost brand new. They literally cost about £25 for the whole board. A fully working board, you can get it for about £25 from eBay. And if you try to go in and remove this CPU, reball it, and then reattach it, you know, you're talking about 3 or 4 hours of work. Okay, now this whole phone at the moment, the G935F, they're not worth, the maximum the cost is about £100, right? So you have to put everything into context here. If you're going to put in 3 to 4 hours of work taking this CPU off, reballing it and reattaching it, right, and then you've got no guarantee, when you're taking it off, you might damage some of the pads. That might increase the amount of hours or the amount of work that you have to do. So it might go to 5 or 6 hours of work. On top of that, once you've reballed it and you've put it all back together, remember, it's not just the CPU here. You also have to reball the RAM on top, okay? Because you don't know, because the heat that you applied, you may have melted some of the bolts under the RAM. So the RAM has to be reballed and attached, and the CPU has to be reballed and attached as well. So easily you're looking at 3-4 hours of work to do that, and there's no guarantee that you're gonna have success. The success rate on these is very low, in my experience. Other people might have different experience, but I'm talking about my experience. So what I would say is, you know what, it's just not worth it. If you have to do all of this work, then, you know, you're gonna charge the customer at least £150 for BGA work like this, right? The phone's not even worth £100. So can you see what I'm trying to say? If you buy a brand new board off eBay, a fully working board, it's going to cost you £25 for the board. You know what? Charge him £50, okay, to change the whole board out. All right. Total is going to cost him is £75. Customer's happy, you're happy, you've made a bit of change, and you've put the phone back on the road instead of going into the trash. You've done a good deed, and you've earned some money as well. What more can you ask for? You know what I mean? See, it's not just about trying to prove to yourself you can do it. As I say, if you're doing it as a hobby and you want to prove to yourself that you can do it and you want to improve your skill, fair enough, go for it. But if you're doing it as a job, you know, you have to put everything into context. That's all I'm saying. Right. While we're here, what I want to do is I want to show you the thermal image, because actually when I took the other one off, this one here, I just wanted to make sure. So what I did was when I took this cover off, I reattached it again to the power supply, and I put power through the board again just to make sure that the heat wasn't coming from here and it was actually coming from here, and I can confirm that all the heat was coming off the CPU. It was at idle, without the phone being switched on, it was consuming about 600 milliamps, and this was, you know, going around about 41 degrees, you know, which is clearly indicates there was a short inside here somewhere. Now let's go over to eBay and let's find a replacement board. I want to show you how to source and find a replacement board, and we'll take it from there. Let's quickly go to eBay. Let's go and type in S7 Edge, EDGE, mainboard, or just type in board. Right. Here we go, look at that. $29.99 to $44.99. Here's one. Mainboard for Samsung S7 Edge G935F, 32 gigabytes, £27. I've seen them for up to £25. S7 Edge board. Here we go. If we go here and if we put lowest price and postage, lowest price and PMP, let's see what comes up. There you go. Here's one for £26. Original mainboard for Samsung Galaxy S7 Edge G935F, 32 gigabytes, 5 available, £26.78. Right. So all we need to do is order this board. Okay. I've actually seen one for £25 the other day. It's probably gone at now, but they do come up quite regularly for about £25. I've seen them for £25 with free shipping. So if you have a look here, £26.78, 32 gigabytes unlocked motherboard, and it says here tested and fully working motherboard for G935F Samsung Galaxy S7 Edge. No FRP, no Google lock. Yeah. Maybe network locked, but even if they are, you can unlock them for £1 online, so that's not an issue. That's what I'm going to do. I'm going to go with this. Now let's get back to the demonstration table. I've actually ordered one of these already, and I'm going to put the phone back together and we should take it from there. Okay, so we've got our replacement mainboard. It's just been delivered, and what we're going to do now is we are going to install it back into the phone, and hopefully all our hard work will have paid off. As you can see, we've got our shiny new board and it's ready to go. Okay, so here we go. The moment of truth. Is it going to work? Is it not going to work? Let's find out. So I've plugged that in, and it says here that it's pulling 4.92 volts and 1.519520 amps. So you can see here that the phone is charging. Okay, now the battery may be a bit low on this because obviously it had some issues with it, but I can see that it's charging clearly. But what I'm still going to do is I'm going to wait and I'm going to switch it on just to make sure everything comes on and it's all working correctly. Okay, so I believe that the phone has enough charge now that we can switch it on and we can show it working on camera. So that's what I'm going to do now. Let's switch it on. And there you have it. Another job well done. I hope you learnt some stuff today regarding mobile phone repair, and I hope you found this video beneficial. Don't forget to like and subscribe, and if you've got something to say, please do leave a comment down below, and hopefully we'll see you in the next one. Bye for now, and have a nice day.